In this video, I am going to explain stop and wait ARQ. Stop and wait ARQ. ARQ means automatic repeat request. Automatic repeat request. Stop and wait ARQ means stop and wait flow control mechanism plus error environment, and error environment means noise channel. During that transmission, suppose that the frame is damaged, the frame is lost, acknowledgement is lost. These are the situations here we have analyzed. That is called as a stop and wait ARQ. The meaning of stop and wait ARQ is stop and wait flow control. Stop and wait flow control plus error analysis. Okay, coming to this one, I will dictate some important point here. First point here is the protocol, one protocol, because the maximum window size here is 1, n is equal to 1. The protocol called 1 bit protocol, 1 bit protocol, because the maximum, the maximum window size here is 1, that is n is equal to 1. Generally, stop and wait ARQ uses stop and wait flow control technique. In this technique, the sender send one frame and wait to get an acknowledgement from the receiver side, and then only send next frame. Second point here is it means stop and wait ARQ uses the stop and wait. It uses the stop and wait flow control. Stop and wait flow control in which the sender sends one frame at a time and waits for an acknowledgement before sending the next frame. Okay. One bit sliding window protocol is called as a stop and wait protocol. And 1 bit, only one frame is sent at a time. That is the reason 1 bit sliding window protocol is called as stop and wait protocol. The sequence of actions takes place in this stop and wait protocol. ARQ is the sequence of events. The sequence of events taking place shown below. Taking place described below. Described below. First one is the data is coming from network layer. First one is the data link layer of the sending machine fetches the first packet from the network layer. Here, the data link layer of the sending machine fetches the first packet from the network layer. It builds the frame for it and sends it to the receiver. Second point is build the frame at the data link layer of the sending side. That frame is placed on the channel. That frame is placed on the channel. Okay. The receiver data link layer on the receiving side machine check the validity of the received data frame. The receiver data link layer check the received frame status. Received frame status means sometimes a duplicate frames are reached. Sometimes that frame is corrupted during its transmission. Bits are changed. These are the status checking at the receiver side of the data link layer. If the error is there in that received frame, ask for retransmission of that frame. If duplicate frame is received, that duplicate frame is rejected. If it is okay, there is no error. It passes the frame to the network layer. There is no error. In the received frame. There is no error in the received frame. Passes through the network layer. It means frame. Frame passes through passes to the network layer. Network layer. There is no error. Schematically, this is the network layer. Network layer on the source side generates some packet. Here, this is the packet. That packet is sent to data link layer on the source side. This one is source. Data link layer. Data link layer. Here add some packet, some redundancy information, some parity or redundancy information trailer. Here some header information is there, header. This is the header information. Header contains the address of the source node and the destination nodes. This is the parity information. Parity means redundancy information. Check the with the help of this redundancy information, check the validity of that packet. Once frame is created, this is the frame. This frame is placed on the transmission media. This one is the transmission media. Transmission media. Frame is reached to destination side data link layer. Destination side data link layer. Header packet from redundancy information. A small group of bits. Redundant information means small group of bits. With the help of this redundancy information, check the validity of the packet which is came from source side. There is no error. That packet, this frame is received frame is sent to network layer. The received frame is sent to network layer. If an error is there, the destination node asks retransmit that error frame. Duplicate frame is received. Duplicate frame is rejected. These are the actual procedure adapted placed in case of stop and wait flow control. Next one, the operational protocol. The operational protocol. The operational protocol is based on ARQ, automatic repeat request principle. The operation of this protocol is based on the ARQ. Later I will explain ARQ importance. Automatic repeat request. Automatic repeat request principle. In this method, the transmitter one frame of data and waits for an acknowledgement from the receiver. In this method, the transmitter sent one frame of data at a time and waits for an acknowledgement. from the receiver. From the receiver. If it receives a positive acknowledgement, it transmits the next frame. If it receives a negative acknowledgement, it retransmits the same frame. Negative acknowledgement means check the validity of the frame at the receiver side. There is an error. Send a NAC frame to sender. If it receives a positive acknowledgement, ACK transmits the next frame. If it receives a negative acknowledgement, if it receives a negative acknowledgement, NAC, negative acknowledgement means NAC. It retransmits the frame, same frame. It retransmits the same frame. This is the source and destination node, sender and receiver. Sender and receiver send data to that receiver. If that data is correctly received without any error, send some ACK. Again, after ACK is received from receiver node to the source node send another data to the receiver. The data is corrupted during its journey. Some noise is added. A NAC negative acknowledgement is sent to source node. This is the timeout period. Timeout period. A NAC. This is the NAC signal is reached to source node. The source node thinking is the previously sent data is corrupted and send again same data to the receiver. Same data to the receiver. Therefore, receiver send that after sending that data, again check the validity of that particular data. Okay, if it is okay, the receiver send positive acknowledgement to the source node. Next, some confusion is there. Which data is sent from source node to receiver node? That is the reason have to introduce some numbers to the numbers added to the data and ACK also in the header field. Futures added for retransmission. Next one. Futures added for retransmission. Okay. For retransmission, 4 futures are added to the basic stop and wait flow control mechanism. Why few transmission? Some errors is there. Without error, that is called as flow control. With error, we have to introduce some retransmission. For retransmission, For retransmission, 4 futures. 4 futures are added. 4 futures are added to the basic stop and wait flow control. Flow control mechanism. Suppose at the source side we have some 7 frames. These 7 frames are stored at the source side because at any time need some retransmission of that particular frames. That is the reason we need to store these frames at the source side. If any damaged frame is reached to the destination node asks a retransmission for that particular frame. That is the reason source keeps the already transmitted frames which are stored in the memory. First one, the transmitter stores the copy of last frame. Copy of last frame transmitted. Last frame transmitted until an acknowledgement for that frame is received from the destination. Storage will need at the source side because suppose one frame is sent, that frame must be stored at the transmitting side until have to receive an acknowledgement from the receiver side, to source. Next, second important point is this point is very, very important for distinctly identifying different types of frames. Both data and ACK frames are numbered alternately 0 and 1. Suppose one frame is sent, that frame is lost during its transmission, and acknowledgement is not came from receiver to source node. At that instant, the source node is in confusion mode. Which data frame is lost during its transmission? That is the reason we have to introduce some numbering system numbered alternately 0 and 1. Suppose this is the data. In the header field of the data, some number is there, 0. This data is sent to the receiver, successfully reached to the receiver. The receiver sent an ACK. The receiver send is an ACK with 1. ACK 1. For data 0 means number ACK number is 1. That means this ACK is particularly meant for this data 0. Suppose data 1 and ACK 0 alternately numbered. For data 0, acknowledgement is ACK 1. For data 1, acknowledgement is ACK 0. For NAC signals, there is no number. The first data frame is sent is number 0. This frame is acknowledged by an ACK1 frame. After receiving ACK1, the sender send the next data frame having a number is 1. For acknowledgement of the data 1 is ACK 0. In this fashion, the process is continuous. The fourth important point here is the transmitter has a timer to take care of the frame ACK which are lost. After specified time, if the transmission does not receive a ACK or NAC frame, it transmits the last frame. Okay. Third important point here is third important. If an error occurs while transmission, the receiver sends a NAC frame back to the transmitter. Back to the transmitter for retransmission. For retransmission of the corrupted frame. NAC frame which are not numbered. Tell the transmitter to retransmit the last frame transmitted. To retransmit the last frame transmitted. When retransmission is necessary, data is lost or data is corrupted, acknowledgement is lost. If the transmitted frame is lost, if the received frame is damaged, if the acknowledgement from the receiver is lost. These are the errors. That is the reason it is called as a stop and wait. Due to these errors, retransmit that particular frame. Automatic repeat request. Automatic repeat request means request to retransmit the damaged frame, last frame transmit. That is called as automatic repeat request. Okay. That retransmission is necessary. The retransmission is necessary the following cases. In the following cases. First one is if the received frame is damaged. Second one, if the transmitted frame is lost. Third one, if the acknowledgement from the receiver is lost. In three cases, we must retransmit the frame from sender to receiver. First one, operation under normal condition. Operation. First one is operation under normal condition. Operation under normal condition means this is the source node, sender, or this one is receiver. The communication path is created between these two, source and receiver. The source node send data with the number is 0. The data is successfully reached to receiver. The receiver send NAC, not NAC, ACK with number 1 within this timeout period. Okay. Next data frame number is data 1. This one is data. Data 1 is sent to the receiver. That is correctly received without any error. The receiver send ACK1, ACK0, not 1, ACK0 to the source node. Once ACK0 is received, the source node send data 0. Data 0 to that receiver. The receiver send ACK1 to source node. Therefore, data frames are alternately numbered 0, 1, 0, 0, 1, 0. Acknowledgements are also alternately numbered. For data 0 frame, the acknowledgement is ACK1. For data 1 frame, the acknowledgement is ACK0. That means error-free environment. This one is particularly when error-free environment, and also stop and wait. This one is error-free environment. Okay. Suppose in this case 2, stop and wait ARQ. Stop and wait ARQ for damaged frame. Damaged frame means this is the sender, receiver. Link is formed here. Bidirectional link. The sender send data 0 to the receiver, correctly reached. That means the ACK1 within this timer period. The source node send. After receiving ACK1, the source node send data 1 to the receiver. The data 1 is reached to the receiver. The receiver check the validity of the data 1 with the help of checksum or error detecting method. Therefore, identify the data 1 is corrupted. The data 1 is corrupted. Therefore, that information is sent to source with the help of NAC, negative acknowledgement. This one is NAC. Negative acknowledgement is sent to the source node within this period, timeout timer period. Therefore, the source node thinking is the data 1 is correctly reached to the receiver node, but the data 1 is damaged. That is the reason already the data 1 is stored at the source side. Due to this NAC frame received from receiver to source node, therefore the source node send again data 1, not data 0. Data 1 to the receiver node. That this data 1 is correctly received. Therefore, the source node, the receiver's node send ACK 0, ACK 0 to source node. This is the procedure exchanges between the source node and the receiver node when frame is damaged. Second one, the third one, normal operation. The frame is damaged. Third one, stop and wait. ARQ, stop and wait ARQ for last data frame. Stop and wait ARQ for last data frame. ARQ means automatic repeat request. This data 1 is reached, check the validity, some error is there, again retransmit the data 1. That is called as a repeat, automatic repeat request. Again, this is the source node, receiver node. The data 0 is sent from source node to receiver node. The receiver node send ACK 1 to the source node from receiver node within this timeout period. The source node send data 1. Data 1. The data 1 is lost. Not reached to receiver node. Set the timeout period. Set the timeout period. The data is lost, not reached to receiver. After a timeout period, the source node thinks that the data is not reached to receiver because acknowledgement is not coming from ACK 0 is not coming from receiver to source node. receiver to source node. Therefore, the source node send again data 1 frame to receiver, data 1 frame to receiver, because within the timeout period, an ACK0 is not reached to source node. Therefore, source node decision changes after a period is completed. Again, resend that last transmitted frame. The last transmitted frame is data 1. Okay. The data 1 is reached to receiver node. The receiver node, it is the data 1 is okay. There is no transmission error. The send ACK0 to the source node. Next one is stop and wait ARQ last ACK frame. Fourth one is stop and wait ARQ last ACK frame. This is the source and receiver. Source and receiver. The source node send data 0. That is, the data 0 is correctly received without any error. Therefore, the receiver node is immediately send ACK1 to the source node. That ACK1 is not reached to source node. Already the receiver having some buffer store this data number, allocated number to the data, that is 0. Okay. Within the timeout period is completed, the source node thinks that the data is lost or the data is not reached to receiver. Even the receiver is sent acknowledgement, the source node thinks that the data is not reached to receiver. Send again same data. Send again same data to that receiver node. Okay. This is the hold the number of that receiver data. 2 times. This is 2 times the data is received. 2 times the data is received. That is called as duplication. Okay. Check the validity. Already the validity is completed. And send ACK1. Therefore, once this data 0 is reached, again send ACK1 to the source node. This duplicate data is discarded. This duplicate data is discarded. Therefore, by using these numbers indicated at the header field of either data and ACK, have to identify the duplicate frames at the receiver side. These are some important actions takes place within the stop and wait ARQ protocol. Disadvantages of stop and wait flow control. Disadvantages of stop and wait flow control. Problem with the stop and wait flow control is that it is very inefficient. First important point. Problem with the stop and wait ARQ protocol is that it is very inefficient. It is very inefficient. At any one moment, only one frame is transmitted. At any one moment, only one frame is in transmission or transition. The sender will have to wait at least one round trip time before sending next. The sender will have to wait at least one round trip time. One round trip time before sending next. Before sending next. One round trip time means from source node to sender, from source node to receiver, send frame, from receiver to source node, an acknowledgement reach to source node. That is a two-way round trip time. Source node to destination node to source node. That is called as a round trip time. The waiting can be long for a slow network such as a satellite link. The waiting can be long for a slow network such as satellite link. Okay. With this, the explanation of this stop and wait ARQ is completed. Stop and wait ARQ means stop and wait flow control mechanism plus some noise. Noises are nothing but the data is lost, the data is damaged, acknowledgement is lost.